load up videos of what we do in class. Close your laptops. I've started doing this back when I taught at Montclair State. It's a commuter school, and it's up in maybe 45 minutes from here in North Jersey. And the students loved it because, especially the high school teachers, I used to teach in a master's program with a lot of high school teachers that were getting a master's, and they were really busy during the day, and when they came at night, they just couldn't pay attention. Sometimes I was teaching and I couldn't pay attention. It was tiring. So having the videos, I stopped doing it initially when I came here because I thought, well, cadets don't need that. And then cadets were using the videos that I had pre-recorded already for Montclair, and I'm like, well, I can do it here. I just record whatever we're doing in class. And so apparently humans are humans anywhere, and it's really hard to pay attention. And when the need arises, like when you're studying for something, that's when you want to pull things down. Everything you see on that playlist is labeled by the topic. That was something that I got feedback on, that, hey, don't just put up the whole lecture, take that specific topic so I can look through your playlist and find it's that thing I need. So today, this thing I'm going to put on as what is a gradient. And on your sheet, add onto the table under gradient of f, it's the third row down. If I have the gradient of a at a point, so I plug in a value, it's the vector perpendicular. Does everybody understand that notation? That means perpendicular. Perpendicular to the contour curve. So it has two things. I put on that table already that for the surface, when you're walking around that surface and you're standing at any XY point, so there's that XY point I'm standing on, anywhere I'm standing is pointing in the direction of the steepest incline right there. So like I turn around and rotate around and go, oh, there's the steepest incline. The gradient would be pointing there. That's for the 3D. If I squish it to the floor, it's perpendicular to the contour curve. So you need both of those things in your head. We used it for the Lagrange stuff. Okay, I'm going to show you a real example. That doesn't go on your table unless you want to. You could have it. I don't think some of you write really small, so you could actually put it on your sheet of like examples if you want. I like examples instead of actually formulas because that makes it all real. I can see it. So let me do a real example. So here's a skill that you guys don't really need that much, but what shape do you think this makes as a surface? It's, well, that you're close.
Yeah.
So x squared by itself, what is it, Jane?
Parabola.
Parabola. And x squared plus y squared equals a constant makes one, a circle. And if the constant, which is the z-axis, is bigger and bigger, you have bigger and bigger circles. It's like the bigger and bigger circles as you get higher and higher, but it doesn't rotate. Like you're thinking of the spiraling curves. This is not a curve, it's an actual surface. But what you're doing is you're stacking circles that are getting bigger and bigger as you go up the circle thing. What's it going to look like? A bowl. So this thing is like a three-dimensional parabola. It's a bowl. But you don't need that skill, I don't think, anymore. Just that was what I used to do when I was, well, I didn't used to do that in this class because I was just trying to get by. I'm not supposed to lie either, right? I'm just telling you the truth. I couldn't see anything. I didn't understand what people were talking about. So I just tried to learn as many formulas as I could and get out. And I thought, well, I will never need that again. Guess what? I needed it again. So, unfortunately. So look at a contour curve. You already told me what this looks like. Contour curves are when you set that equal to a constant. You already told me what that is. It makes a shape of what? Circle. Square to C. If I give you a specific point, like x0 equals 1, y0 equals 0, well, the level curves of this, I made them super easy. They're going to be like circles that just keep getting bigger and bigger the more you go out. So let's say I have this point right here. That's x equals the x value 0 and the y value. And what's happened is like this hole, you stomped on it and all the like cross sections fell down. Have you ever seen those toys that kids put together with little pipes that they put together on the pegs? Babies play with it. That thing, like if you took it apart, you squished it down, it would look like this. If you could squish it down. Right here at this point, I can calculate the gradient, and the gradient would be two x, 2y. If they ask for the gradient, put a vector, because if you don't, then it immediately alerts the person grading it that, oh, they don't know what they're doing. It's a vector. If you plug in the point x equals 1, y equals 0, I get 2, 2. And I can plot that vector. Sorry, 2, 0. Numbers are hard for me. And I can plot that vector. 2, 0 looks like over 2 up 0. It looks like this. And it indeed is perpendicular to that point. Right there is perpendicular. Ready to teach for me? I'll happily sit in your spot. This time I would study. This time around I would study. If someone else gets up here and lectures and gives me homework to do, I would do it this time. All right, so everybody have this down? Let's pick another point. I thought an interesting one would be, I think I took 1/2 and squared root of 3 over 2. Go ahead, ask. How did you draw that? 0, if I went over 2, like on the, just like you did back at the beginning of class, over 2, it just, this is my imaginary 2, but I didn't put units on it. So but yeah, just that's the gradient at that point. Okay. Right. So if I took x0 equals 1/2 and y0 equals square root of 3 over 2, well, I'm just going to redraw it here. Here's one of my contour curves, and if I specify that point is somewhere here. So these are ocular regression. I'm just eyeballing it. And then if I computed the gradient vector at that point, I get 2 times 1/2, which is 1, and square root of 3. That's the vector I get. So that means I go over 1 and up 0.8, something like this. Did I draw this right? And it's not 0.8. Square root of 3 is bigger than that. Square root of 3 is up here. So it's something like this. So if I drew everything perfectly, it would be perpendicular right at that point. I haven't drawn things nicely. I've got a crazy looking circle that's not centered, but you could picture, like if I draw it very nicely, that vector would go slice right through that point and be perpendicular to the little tangent line right at that point, if I draw it nicely.
That's still for the same equation.
This is all still for the same equation. So that's what I mean. I just wanted to make it real to you what I mean by vector, at a point, gradient, so you can see it. So you can experiment around. That was like a CalPlot 3D. They actually had a computer do it for you so you can see it. But this would be a real example of what it shows you. All right, does that help a little bit with what we did yesterday? All right, I'm gonna do monkey see, monkey do. I'm gonna do one, and then you monkeys are gonna go and do the same thing, right? Don't they call your gray cadet uniform, the gray one, the monkey suit? Never heard that. I don't know if this is true, but I heard that the winged monkeys got that particular outfit. If you look at the winged monkeys in Wizard of Oz, they have like a cadet uniform type outfit.
I've actually heard that as well.
I also heard that David Lee Roth came here for our day and went away right away. I don't know if that's true either. If you don't know who David Lee Roth is, don't tell me that. It'll make me feel bad. He was the lead singer of Van Halen. All right, this is the how-to. Like you guys were asking the right question. Yesterday, like you had this thing where you had the hiking trail, which was your G, and then you had your F, which is your surface, and then you found out that the gradient of F is equal to some scalar multiple of the gradient of G. That's what you really found at the maxes and mins. When you are finding any of the max min problems, you're setting up all the different points that are your suspects, and then you're finding from a table which ones are the maxes and mins. That is the same as what we did with the domain one yesterday. I don't think you have any more domain exercises in your WebAssign, so I'll give you some like this. Let me